Let's Go to Space, Blue Sky Learning, episode 143, Software in Space from Florida Atlantic University. Today, Kevin and I meet with Alex Castronovo, a 17-year-old student at Florida Atlantic University High School and a longtime Wolfpack member. Alex has demonstrated proficiency in software development with contributions in neuroscience research as a research fellow at the Max Planck Florida Institute for Neuroscience. His work includes the development of a software tool for analyzing synapses in electron microscopy images. Alex's academic achievements extend to astrophysics and aerospace, with several publications in peer-reviewed journals and international conference proceedings. Some of his personal projects include Launchify, a web application providing customizable rocket launch notifications, and Jangle, a Java graphics library simplifying 2D graphics development. His numerous awards include a first-place win in the QubitX Hacks competition, and all of this shows his commitments in the field of software development and scientific research. As always, we look forward to hearing more from Alex, and we know that you're going to enjoy this episode as much as we do. Welcome, Alex Castronovo. We're so grateful that you can spend some time with us this weekend. Now, tell our audience members a little bit about yourself.
Sure. So, I'm a 17-year-old at Florida Atlantic University High School on the Jupiter campus, and I've been there since 10th grade. I'm also a part of the Wolfpack CubeSat development team, and there I'm the lead of the software team for our next satellite, WolfSat-1. So I'm sure we're going to talk more about that today too. And for fun, I love programming. So actually my major in Florida Atlantic University is data analytics, but I also love graphics programming, which is communicating with the graphics card which is being able to render images to the screen using the graphics card.
Pretty impressive. Now, you've been with the Wolfpack for quite some time. I mean, I think it's been like 6 years, something like that.
Yeah, I think it's almost been 6 years.
Yeah.
So I started in 6th grade. So at the Y School when I joined U2. But then when this organization split from the Y School, I stayed with you guys. So here I am till this day.
Yeah.
I think the first memories, really good memories I have of you, Alex, in the 6th grade. It seems like I assigned everyone to create a spreadsheet based on the orbital mechanics we were learning. And I think you did very well on the spreadsheet to sort of model the height and speed of something like the ISS based on the orbital parameters like semi-major axis and things like that. Do you recall that exercise?
Yeah, I do recall that exercise. Actually, you assigned us, I think, a couple Hohmann transfers to do, which is the simplest type of orbital transfer to get from one orbit to another. And I didn't feel like doing all those by hand or by spreadsheet. So instead, I created a Python program to automatically calculate them for me. And that was actually the first, and that was the birth of the project that became a presentation at the International Astronautical Congress in Paris in 2022.
That's right.
Yeah, good times.
Well, let's fast forward to now and talk about, you're involved in many different projects, right? And why don't we go ahead and start with what you're doing at FAU High School, and maybe for our listeners who aren't familiar with how that school works, it's a little different from a normal high school. So tell us a little bit about, the kind of the university high school program, what it does, how you can kind of earn your credits towards the degree while you're doing it, and then the projects that you're working on.
Sure. Yeah. So at FAU High School, it's very different. So it's technically a dual enrollment program, which means that I would take college credits while in high school. But the difference between this and other dual enrollment programs is that with most dual enrollment, you would have maybe 1 or 2 college classes and the rest are high school. Here I have all college classes, and then those backfill high school requirements. So I'm on the college campus with college students, and I'm rarely ever in the high school building.
So So you are earning a bachelor's degree while you complete high school.
Correct. And I'm on track to get that bachelor's degree 1 year after I graduate high school.
Yeah, that's one of the great draws about that program. And I think also, being on a college campus, I mean, obviously that requires you to be a pretty mature student to be able to navigate that. But what kind of research are you, with choosing FAU High School, you chose that obviously for a reason, one of your areas of research. What are you working on with them, and how does, being a member of that school allow you to do that?
Sure. So the Florida Atlantic University Jupiter campus has three separate institutions within a half mile of each other. So you have FAU Jupiter, where I attend school. You also have UF Scripps, and you also have the Max Planck Florida Institute for Neuroscience. So last summer, I was able to get a fellowship at the Max Planck Florida Institute for Neuroscience. It's called the Magar Fellowship, which is a data science fellowship. And I worked with them with creating software tools to automate lengthy workflows that would otherwise take hundreds of hours to do manually. For each synapse we analyze, which is within the neuron, which is within the brain, with each synapse that we analyzed would have taken us like 15 minutes previously, and I got that down to 1 second.
Wow,
Fantastic.
using kind of the same kind of idea that you had when you were doing the home and transfer, similarly trying to take a larger problem and solve it faster.
Yeah, just getting rid of the manual work that's required and just doing it automatically.
Did you create intellectual property that you now own? Is that something, or are you is the work that you do, is it owned by Max Planck?
I'm not entirely sure how the IP works there, but I'm pretty sure that any work that I produce there is now owned by Max Planck.
Right.
Yeah.
So you've done them a really good favor, right? I believe you,
Yes, yeah.
and you were able to present this work already, haven't you?
Yeah, so I presented this at the Florida Atlantic University, at the FAU, at the FAU Summer Symposium. So I did a poster presentation there. And then I did more further analysis with my program. And now I'm going to be presenting it again this March at the Florida Atlantic University Spring Symposium as an oral presentation too.
It's pretty
Fantastic.
cool.
So you have taken your what I would consider subject matter expertise, and you're able to apply it to different fields, right? Different research areas, because the work you do for the Wolfpack is quite different than that as well. Would you say that's a fair statement?
On the surface, I would, but when you actually look at the techniques that I would use for each, for Wolfpack versus analyzing a neuroscience data set, some of the techniques are actually surprisingly similar. Actually, there's this other preprint that I made about analyzing the galaxy filaments and how they are networked in this network-like structure. And a lot of techniques I used in that paper could be applied to my neuroscience data set. So it's amazing how something so big or so small or somewhere in between can all use the same
Same kind of
techniques.
thing. So for our listeners who might be not familiar with what a data analyst does, right? Can you kind of give us a kind of a very rudimentary understanding of that? And then what I'd like you to then take that onto is let's discuss some of those techniques. So you're saying that you're applying these techniques to different kinds of problems. So let's start first with data analytics.
Sure. So I come from a primarily programming background. So I really try to analyze big data sets using statistics and programming. And that's what data analytics is, the kind of union of both the statistics and programming fields to essentially draw insights from otherwise, which is millions of points, right? So what I did, the technique that was similar was using graph theory to analyze the network structure of the galaxy filaments. So essentially what I did is I found a tree that spans the entire data set. So a tree means that it has no loops within the graph. And trying to, sorry.
I know it's hard to explain for people like me, isn't it, Alex?
Yeah.
But let me posit
Okay.
this, Alex. Only someone with really deep domain expertise would see the similarities in the analyzing galaxy formation and structure of the universe versus an individual microscopic neuron and something barely, on the macro scale, like working with CubeSats.
But I can see why you would want a computer to do that, because it would be almost impossible
Yeah.
for a human to do that, let alone as quickly. So for the computer,
I think, how about this statement, and then modify this and correct it. You use your programming tool set to find patterns or to create models within the large data sets. I'll let you build on that. Fix it or build that statement.
Yeah. So find patterns or build models. I think that's approximately accurate. One thing that I like doing with these data sets is actually simplifying them. So let's say you have 4 million data points. You could, I don't know, use AI to, let's say, classify them into 20 different types. And then once you have those 20 different types, you can analyze each type individually using some other method. Another project I'm working on at Max Planck is one we just got started on. And essentially it's automatically segmenting the dendritic spine head from the dendritic spine. So within a neuron, they connect with other neurons, or they reach out to connect to other neurons using dendrites. And within these dendrites, you have little protrusions, which are called spines. And these spines kind of have a mushroom-like shape on the end of them, which we call the spine head. And we want to, and it's scientifically important to analyze these spine heads for us. So previously we would cut these spine heads off from the spines, and this would be a long manual process. But what I'm doing now is going to be classifying different types of spine heads and then applying slightly different algorithms for each spine head to take out the spine head segmentation from to segment the spine head from the spine.
So the spine head and an adjacent spine head, is that the region that is the synapse, that is where the information gets exchanged chemically between two neurons?
Yeah, so the synapse is within the spine head, and that's connected to a presynaptic bouton. So the synapse has both a presynaptic and postsynaptic side that would that together forms the synapse, which sends chemical information.
So as you began down your programming journey, now you're into data analytics. Did you think you would end up being in the world of neuroscience?
Not at all. When I started my programming journey, when my father taught me my first line of code at age 8, I did not think that I would be analyzing neuroscience data sets 9 years later.
Yeah,
That is not.
I have a question about, like, just again, because I'm not the math persons here clearly, but when I think about what he's talking about, and also when I think about like Sophia and the Monte Carlo thing or whatever, is the Monte Carlo method taking data sets like what Alex is talking about here and working with them at all? Is it similar?
Well, it's definitely a mathematical process, and you're considering all the probabilities, right? All the potential outcomes and if you get enough, if you consider enough events, right, you can sort of model what is
something. So,
more likely
Yeah.
to.
I guess my next question is, could someone who is working on a Monte Carlo method work with someone like Alex to refine or to program, I guess, doing a Monte Carlo estimation?
I think I'll let Alex. Alex, what are your thoughts on that?
So I think within these large data sets, you could apply Monte Carlo algorithms depending on what the data set is. Um, at my Max Planck work, I haven't actually implemented a Monte Carlo algorithm yet, but in some of my personal projects, I have. So I mentioned before, I like graphics programming. One thing that I'm working on now for the past couple months is a path tracer. So essentially, you simulate how light bounces through a scene, and then finally, once you simulate, let's say 32 bounces for one pixel, then you get the color of that pixel. But what happens is you get a really grainy image because a lot of the pixels just don't hit a light source. So what you can do is you can implement Monte Carlo algorithms where essentially you simulate that pixel millions, if not billions of times, and then you average out each sample, and then it slowly gets closer to the uh, ground truth result. So that's what a Monte Carlo algorithm is essentially, just doing a simulation millions of times, and then it approaches the actual result as it gets to infinity.
Yeah, I would imagine things like pharmacology studies, if you wanted to predict maybe what the effects of maybe a drug might be or interactions within a cell, Monte Carlo might be good for that. Let's pivot now, Alex, to the important work that you do on our Wolfpack team. And for our listeners, the Wolfpack, essentially, this group of students of which Alex was there very near the beginning. We've been around for about 10 years now, and we had a couple of names, but the Wolfpack has been our final name for the last 5 years or so. We're working on our fourth spacecraft. You know, we had three launched, and you have a pivotal part in that. Maybe you could discuss briefly what's the mission statement and why is this such a difficult mission to pull off?
Sure. So the CubeSat we're working on is called WolfSat-1, and it aims to study this type of bacteria that can essentially digest plastic, and we're trying to see how well it can do that in space. So the type of plastic that it's digesting is PET plastic, which I'm not sure what that.
Terephthalate, right?
Polyethylene terephthalate is, yes.
Yeah. So basically, we're measuring how the rate at which it can digest this plastic, both on the ground and in space, and we're going to be comparing both. And this is such a difficult mission because this is something that would generally be done in a lab on a bench. And then what we need to do is essentially package our own like mini lab in a zero gravity vacuum environment. And then if anything goes wrong, we can't service it. It's orbiting around the Earth at 17,000 kilometers per hour. So it's not it's incredibly difficult because of that.
So
Yeah.
what is
And I'm sorry, it's 17,000 or so miles an hour. It's about 24,000 kilometers an hour.
so what is your role with that? Are you doing something with coding like the payload, or like what exactly is your portion?
So I'm the lead of the programming team, but our responsibilities actually go much farther than just programming. So it's almost so previously, before this project, I only really coded software and printed it to the screen or printed it to a file. Here, we actually need to communicate with hardware that we also design. So we have these printed circuit boards, PCBs, that we design, and these models and these CAD models that our team makes. And then we have to figure out how to make the software communicate with that other thing that we designed, and then how we would fit it in this 10 by 10 by 10 centimeter CubeSat.
So, and it's not even a full 10 by 10 by 10 centimeters. It's really about 45% of that volume. And I think the point that maybe you undersold here is the hardware to conduct this mission does not exist. So not only in addition to writing the code for talking to the bus, You are leading the kids that are actually designing the actual hardware on which these bacteria will be evaluated. So that's pretty cool to build something that's never been built, to do a mission that's never been flown.
Exactly. The hardware just doesn't exist.
Yeah.
So
Do
we have to
you
build it
feel
ourselves.
pressure? Do you feel any pressure as having such an important job with the team and the need to make all of this survive liftoff and all the the vibrations of liftoff and like you said the vacuum, and does that ever cause any, do you ever go, wow, that's a pretty tough task?
Yeah, I definitely feel the pressure, especially when I'm just thinking about the scale of this entire project, how uh, high schoolers are putting together this satellite and putting it into space, and just um, how many things need to go right. It's definitely stressful at times.
Well, especially because, like you're pointing out, you guys also have school and you have other things, right? So the time
Exactly.
factor alone must be very difficult.
I think I know one of the ways that you relax, but the audience doesn't yet. I think you're pretty accomplished for things like you play the piano very well, and I think you maybe enjoy jazz. Maybe speak a little bit about one of the ways you unwind.
Sure. So piano is definitely a way I unwind. So I've been playing piano for approximately 6 years, but around 2 years ago, I discovered jazz. And ever since then, I've really just been enjoying it in a way that I haven't before. I first knew I discovered jazz when my piano teacher, who was basically a classical pianist, he made this arrangement of Fly Me to the Moon for me to learn. And then when I learned it, I essentially just threw it out the window and made my own version, which is
Well, I would
what a jazz pianist would
That's what
do.
they would do, right? I remember my daughter
Yeah,
was taking classical piano, but then she took a class through Juilliard that was jazz. It was completely different, but I think it's very similar to what you do with your programming, right? You're
Yeah.
taking apart something that already is like one way, but you're making it your own. You're deconstructing and kind of flipping it that way.
yeah. I especially like with my programming, I like to go to some of the lowest levels that I can go to, just for fun, because I think it's really fun to uh, deconstruct something, maybe look at how something else is made, and then just make it myself again.
Yeah, it's like reimagining.
Yeah,
Well, it, I was going to ask you too about leading a group. So it's important that you obviously have an outlet, right? There have to be challenges besides just the time constraints. What are some of the challenges you have leading a group that essentially meets online? And like, what are your biggest issues as far as the leader goes?
yeah. So one challenge early on to the group was actually the knowledge. Not many people in the programming team knew how to program.
Right, they just
So
wanted to, right? They wanted to create video games.
yeah, they wanted to. So the first, I think, couple months of the programming team was just teaching them the C programming language in general, and then from there we can move on to how to control our payload board specifically, which we chose to be the Arduino because of its documentation and because it works for our purposes.
Yeah, I mean, it's so valuable that you have that knowledge. That's something, of course, that Mr. Simmons would not be able to do without your help. So you're
Yeah,
a really important member, of the team.
And then I know one of the issues we've had recently, which isn't has nothing to do with you and your team, is the manufacturer of our engineering unit. We've been slow to get our engineering model, which I know is something that will allow you to interface with. And, we're starting to bring all the concepts and ideas you have into the real world, right? Plus,
hmm
I know you didn't mention it, but you have a teammate that's actually in another country. So we have all the time differences, the time delays, the separation. Could you speak briefly about this first circuit board? This is our fourth spacecraft, but the first time that the Wolfpack kids have designed their own board. Could you speak just a little bit about if that was enjoyable, if it was difficult, maybe what the purpose of the board is?
sure. So essentially, the purpose of our board, the printed circuit board, is to connect everything together in a very tight form factor, rigid way that will survive the vibrations of launch. and also won't get, disconnected in space, for example. So actually, the person who designed this board, his name is Eric Hoff. He is in Norway, or was in Norway when he designed the board. So what he would do is he learned the software called KiCad, and he would design the board. We would talk about the board and discuss modifications to it every week. And then eventually we created a final design. He would send the files to us. We'd get them printed in China, shipped to us, and then we would test them and make sure that they work. And then, of course, we try to get the boards to him when we can. So he attended the International Astronautical Congress 2024. So we made sure to bring some boards to him so he can see his work in person too.
Well, I mean, you're going to see him in Scotland, right?
Yeah, next
Kevin?
month.
So we can get him some boards in March.
But would you say you have good kids working for you, and are you enjoying the role of a leader? Because you may not have that may not have been your plan 4 or 5 years ago, that you would lead a team, not just be really good at your subject.
Definitely. I can't do it without I can't do it without them either. Eric learning that software, he knows it better than I do. So any PCB stuff, I almost feel like I'm a manager now, because I know who does what and I can assign the work. So I know that one team member can do CAD, another team member does soldering and putting the boards together, another team member designs the boards, and then I have a couple team members that can actually code the hardware of the satellite now. So it's really kind of like orchestrating a symphony.
Well, I think then you have to credit yourself as a great leader then, because it sounds like it functions very well, that you not only have found the skill set that your teammates have, you've taught them some of the skills that they needed, and now you're kind of and they seem to respond well to you. So congratulations on that. Not everyone can effectively lead, right? Some people are great teammates. Some people only like to work by themselves. You're leading a team that's working well.
Thank you.
Yeah, and as someone who's watched you, grow up, basically, the hard part, Alex, is how do we get mentoring so that you can replace yourself when you go off to college? See, that's the hard part, is you've got all this institutional knowledge, but how do we make sure you keep it, we transfer it to that next generation? That's the hard part in all of this.
Well,
Right.
Alex, I want to make sure that we give you some time to talk about, you created an app, since we have a lot of space lovers on this show, that really helps people figure out when it's time to step outside. Do you want to talk about that a little bit?
Yeah. So ever since I was maybe 10, I loved watching rocket launches. Even out of my window, I can see them because I live about 100 miles south of the Space Coast. So I can just look out my window, see the rocket go up, and then within 5 minutes, go back to whatever I was doing. But the main problem was keeping track of when they launch, because the schedules always change. They can be scrubbed 5 minutes before launch, even 1 second before launch. Other times, I just didn't know it was going up at all. So it's really hard to keep track of that. So instead, I created a tool or a service that texts you either like 24 hours, 12 hours, even 5 minutes before launch if you really want that. So you know exactly when to look for it. So it's called Launchify, and you can access it at launchify.live. And that is really that really solves my issue. And I've turned it into a service.
I actually get it as an email notification. So I know every day we're basically, somebody's launching a rocket every day in the US, either from Vandenberg or primarily or Florida. So I know I see your work every day in my inbox.
Alex, if you send me an email for the next newsletter, I'll put some information, a little write-up in the newsletter for those who, maybe don't know about it. It's hard to keep up with all that the Wolfpack is doing, right? But I think a lot of our members, and certainly for our listeners who now can just go to download that app, right? Make sure we can get more people.
Yeah, you don't even have to download anything. You just make an account.
You just make an account.
It's launchify.com.
Launchify.live. So
Launchify.live.
www.launchify.live
Thank you.
is the URL.
That way you have your plug. Well, our last question generally is going to be about, well, I have two questions for you. So the first one is, what are your plans after college? What do you want to do? And then I'm going to give you the last question.
So after college, I'm considering computer science, or who knows, even maybe neuroscience or research with the work at Max Planck. And then of course aerospace engineering is also an option. So I'm kind of undecided between the three right now, but
Yeah, but I think you could still dabble in the others, whatever path you choose, right? I think that there's some overlap, and you seem to have found that. I think you described yourself as an orchestrator. No, what is the leader of the
Manager.
orchestra? The orchestrator,
Oh, a
but
conductor.
a conductor. You're like a conductor leading your orchestra, right? So I like that analogy because they kind of work within to create a beautiful piece. And at least you found a way to take the different parts to compose your own. That really is kind of like when I listen to you talk, that's kind of like what I glean is you've taken all these bits and pieces of things and you've recreated them into something unique. And that's you. That's pretty awesome. All right, my last question is about pieces of advice, right? So we have a lot of listeners, maybe your age younger, and even people who are in college. So like if somebody's interested in pursuing something like what you're doing, or just in general, how do you inspire this next generation?
so that's a tough question.
How about just advice? What advice do you have for those coming behind you as far as maybe pursuing a passion?
Yeah, let's say there's an 11-year-old, right? 11, 12-year-old kid, or maybe a little younger, maybe a little older. If you had to advise them, what do you say to them?
Um, well, personally, what really influenced me um, is to learn programming. Programming, even though it may not seem that useful, I just even use it in everyday life. Let's say there's a file that I need to parse, or I can save a lot of time. Or if there's a satellite that you need to build, you can program it. It could really be a task that can save you 5 minutes of work daily, or a task that you can use for building a satellite or something more than that. It's really something that can be it's such a useful skill, in my opinion, that could really be applied anywhere.
Let me follow up with her question with, as a more general, in more general advice, what would you say to a young person for them to have a very fulfilling, successful, ever how they
Or
define
maybe how
success?
you credit your own success.
Right.
What did you do
Yeah,
along the way
In
to get
addition
that?
to programming,
Right.
how
yeah.
do you make, what do you say to that young person?
I would say ask a lot of questions, be curious, and then when you ask that question, try to find the answer to that question. Um, I remember even when I was like 5 years old, I would say, what if there was a chair propelled by light, and then this chair goes across the world, goes around the world, and it would essentially be a time machine due to the relativistic effects of that chair. Um, and then that actually is very in line with what solar sails do, and how they can propel themselves in space. So, as if you have a question, uh, answer it or try to answer it, and then who knows, maybe you'll be inventing the next solar
The
sail.
next chair, right? That goes around the world, right? Exactly that. No, this is.
Yeah,
But I think your point is important but you got not give up if you don't get the answer right away, right?
definitely.
Just keep asking it. All right. Well, Alex, thanks so much for spending your time with us today. And it seems like so many great things are going to happen for you. So exciting. We'll look forward to talking with you again.
All right. Thank you.
Thank you, Alex.